Okay, so the big question for today is really thinking about what properties can I use to describe matter. Objectives today, we have two of them, are really to identify ways to measure, um, measurement, this is not a sentence, not correct. So ways to measure the quantity of matter. So different ways of doing that. We also want to use specific properties to compare and identify different samples of matter. And since this is the first day that we're reading a book, here's the book that we have, and you can have a copy as well printed out if you have that capability. Otherwise, it will be on the screen. The book is called Investigating Matter. It's your reader. And you can see on this cover, we have a number of tools that will help us investigate matter. And I can see here, it says gas, liquid, solid. And up here, it says chemical chain. So these are some of the topics that we might be covering over the next several lessons. Here is a table of contents. You can see here what we have 6 different chapters. Today, we're going to read chapter 1, Properties of Matter. But looking ahead, I can also see that I'll be learning, or will be learning, about how matter changes, and then even learning about the language of chemistry. So let's get started with chapter 1, Properties of Matter. Everywhere you look, there are objects to describe. What do all of these have in common? They are made of matter. Everything in the universe is made up of matter. This includes all solids, liquids, and gases. Matter is anything that has mass and takes up space. Wow, that's a pretty important thing, that everything in the universe, everything is made up of matter. And then here's a definition: is matter is anything that takes up space and has mass. It's easy to name many different kinds of matter. Just think what you can see and touch. You can see and touch a rope, a fish, a boat, or water. But there's also matter that you cannot see and matter that isn't easy to touch. Air is matter. It has mass and takes up space. You can't see air or grab it, though you can feel it as wind. Blow up a balloon with air, and you can see that the air takes up space inside. Air is matter because the gases in it have mass and take up space. This is another important idea about matter, is that you can't always see it or touch it with your bare hands and your bare eyes. For example, I can think of several things that you really can't see. For example, inside, I know I have white blood cells that fight off diseases when I get sick, and even red blood cells. But when I look at myself, I can't see the blood, but I know that it's there. Obviously, if I cut myself, then I can see the blood. Other things are, I know that in my garden that I have, that in the soil, there are different kinds of bacteria that live in it, because some of them are good and some of them are bad. But those are little microorganisms. I can't see them unless I have like a microscope in order to find them and identify them. But I know that they are there because I can see when things are breaking down, and then they get turned into, back to Mother Nature, right? So that's matter. How many different kinds of matter can you identify in this picture? Take a moment, see what you see. We can certainly name many different kinds of matter in this picture. For example, here's the rope. That's made of matter. Okay, here's a rope here. There's some rope there. This mast is made up of matter. And these are all solid. Right, the boat is made of matter. It's solid. And then I have water all around it. And I can see a blue sky, so we know there's air. And then I guess these are mostly blue sky, although these look a little bit like clouds, so that's matter as well. Weight and volume help describe amounts of matter. Mass and weight. All right, so let me just back up a little bit. Weight and volume help describe amounts of matter. That's in purple. It's the heading of this section. So I'm going to learn about weight and volume. Brian talked a little bit about that in talking about both the marble and the tennis ball, and as well as the chalk. So mass and weight. Some objects are made up of more matter than others. Mass refers to the amount of matter an object is made of. A cotton ball has a small mass. Okay, so I can picture a cotton ball, and I know they're pretty light, so if it's light, then it has small mass. It doesn't have as much in it. A rock that is the same size as the cotton ball has a greater mass. So the rock, the cotton ball, rock's going to be a little bit heavier. The rock contains more matter than the cotton ball, even though the two objects are the same size. So that's really important that we understand that mass isn't about the size of the object, but really about how much stuff is inside of it, how much of matter is there. For example, I could have two boxes, and they could be the same size and shape. But one might have more mass in it because maybe that box is made out of wood. But the other box is made out of plastic. So one might just have less mass than the other. So they don't always have to be, size doesn't really have anything to do with it. You can tell which of the two objects has more matter by weighing each one. Earth's gravity pulls on all matter near the planet. You can measure the force of gravity on an object by placing it on a scale. So here is the scale, and when I put things on it, it can tell me how much it weighs or how much mass it has. So you can see from this tool that it doesn't measure how big something is. Because when you put something on the scale, it pushes down on it. And it tells us how much it weighs. Scales determine an object's weight. The more matter an object contains, the greater the pull of gravity on it, and the more it weighs. So weight has something to do with gravity as far as how much it's pulling on it. How much gravity is pulling on that object. Which makes sense for the scale, because that scale goes down since gravity is helping to pull it down, but this is a device that can measure how much weight it has. Now we have volume. All matter takes up space. When you breathe in, air takes up space in your lungs. You can measure how much space an object takes up using tools, such as graduated cylinders and rulers to determine dimensions. These tools help you to measure the volume of an object. So I see here in this sentence about some of the tools. I know what a ruler is, but what are graduated cylinders? Now, I'm noticing that there's a picture here of this object that I've never seen before. Maybe you haven't seen before either. So I'm going to guess that this is probably a graduated cylinder. And if it's a graduated cylinder, it looks like it's a tool to measure liquid. So I wouldn't put liquid on a scale, or at least not in the way that we would put liquid into the graduated cylinder here. So here I'm measuring volume with a graduated cylinder. And I can measure the volume of a box by measuring its sides with a ruler. So let's look at this diagram or this picture at the bottom. What does it say? A piece of bread can be described using weight and volume. If it is squeezed into a tight lump, it will take up less space. The weight will be the same, but the volume will be reduced. You can see definitely here are the dimensions here, where the arrows are. That's where I would measure if I had a ruler. And as you see, it's got squished down to a ball. But I haven't done anything with the bread as far as I haven't taken any of the bread away. It's still the same amount of bread. So it has the same mass, even though it's a different shape. Now we have another heading. Properties describe and help to identify matter, or identify types of matter. Measurements such as weight and volume help us describe the amount of matter in objects. But we use other means to describe matter. When we describe how a material looks, feels, or behaves, we are describing the material's properties. And I can see here in my vocabulary box, it has property, which is a singular form for properties. A property is a quality, trait, or detail used to describe something. In this case, I think we're talking about physical properties because that's what Brian was talking about before. What is a solid matter in this picture? You might have identified the glass, but you could also identify the cubes. See this picture here? I've got glass. Inside the glass is water, and outside glass are the ice cubes. If asked to identify the transparent material you can see through, you could have named the glass, the ice, and the water. But let's think about how else we could describe these objects. What other properties do they have? What is the difference between the glass and the ice, though they are both solids that look a lot alike? You might explain that the ice cubes will melt at room temperature, but the glass will not. We can use a combination of properties to describe different examples of matter and tell them apart. This caption here actually went with this picture behind from the last slide with the glass, that water, and the ice cubes. Let's read about this section in purple. It's not part of the main text, but it's so important to read. Think about melting. Ice melts at 32 degrees Fahrenheit. Other substances, such as steel, have different properties and do not melt until the temperature is much hotter. Steel is made of a combination of metals that does not melt until the temperature reaches around 2,500 degrees Fahrenheit. The temperature at which an object melts, its melting point, is a property of matter. That is amazing. So that's another property here, a melting point. Wow, such variance. The ice melting at 32 degrees, and the steel not even melting until 2,500 degrees. That's really, really hot. Matter has physical properties. Solubility. If you crush a sugar cube, you know that the powder that results is still sugar. You still have the same amount of sugar. You could even measure the weight to be sure. But what if you mix the sugar into a cup of tea and stir it? The sugar seems to disappear. When you taste the tea, how can you tell the sugar is still there? Well, it tastes sweeter. The sugar has dissolved in the tea. Tea is mostly water. The property of how matter dissolves is called solubility. So the solubility, we're talking about how something dissolves in water But the dissolving doesn't mean it disappears. It's still there. You just cannot see it, I guess. Sugar is a type of matter that dissolves in water very easily. It has a high solubility. Sand does not dissolve in water and has low solubility. Oh, if I think about that, that's true, because like when you go to the beach and there is sand, it's still there. It doesn't go anywhere. It never disappears. You can see the sand in the water, no matter how many times you stir it around in your bucket when you're making sand castles, it's still there. How might you describe the differences between table salt, sugar, and white spot sand that you find on a beach? Well, I know that salt is salty and sugar is sweet, and I wouldn't want to eat white sand. But I feel like that's not really how scientists figure out what those substances are. They don't put them in their mouth to find out. So one way might be to test the solubility of each. Table salt looks a lot like sugar, but the salt takes longer to dissolve in water than sugar. White beach sand looks a lot like sugar and salt, but it won't dissolve in a glass of water at all. Like other properties, solubility allows you to describe and identify the matter you see around you. So I get that about the solubility, but I'm kind of thinking about, like, if you're writing the solubility test, it doesn't mean you're like timing it or looking at it. I'm kind of curious how all that works, because it talks here, or it says here, the salt takes longer. That makes it seem like at some point they must be timing it. But in any case, solubility is one property I can use to describe matter. Knowing the properties of matter can help us identify materials and use them to solve engineering problems. Look at the physical properties of a rock called pumice and the metal copper. This is pumice on the top. It has a bunch of holes in it. And this is copper with the coils. Okay, so one property you can look at is color. Though it can be darker, pumice is usually light tan or gray. What color is the copper? Well, it's copper. Copper is so recognizable by the property called color that the name of the color and the name of the mineral are the same. Hardness. Some rocks and minerals are harder than others. Hardness is tested by scratching the materials with each other to determine which is harder. This is called a scratch test, which you can use to show that copper is harder than pumice. This makes me wonder about what the hardest substance is, or what the softest substance is, or at least in terms of minerals and rocks. Since they're comparing these two, I'll have to look that up later if I want to know. Reflectivity. When you look in the mirror, you see your image in a shiny, reflective surface. Many rocks and minerals have shiny surfaces that reflect light. Metals, such as copper, have high reflectivity. Dull materials, such as pumice, have low reflectivity. Buoyancy. Pumice is an unusual rock because it floats in water. Pumice floats because the matter in the rock is more spread out than the matter in the water. Buoyancy describes an object's ability to float. The more buoyant an object is, the more likely it will float. Copper is not considered buoyant because it sinks. All right, so I've got reflectivity on this page, which is basically telling me, is something shiny or is it dull? And then I have buoyancy, which is, does the object float or does it sink? And so in addition to color and hardness, now we have a total of 4 physical properties that we've learned about so far. Metals have certain properties. People use the properties of matter to describe different metals as well. Copper, iron, aluminum, and stainless steel are all metals, but they have different properties. Let's look at three properties that these metals share to varying degrees. Electrical conductivity. Copper is used for wires because it is a metal that conducts electricity. An electric current passes through it easily, but an electric current is not conducted at all through the plastic coating on wire. Metals vary in their ability to conduct an electric current. Now, thinking back to the other page when it talked about how engineers need to consider different objects' properties, and that's what they analyze and determine in order to select the right materials for different purposes. So it's important for them to know things like that copper conducts electricity better than other metals, so that when you're building your house, you have copper wires inside. Or when you have your Christmas lights, if you ever open that up, there are copper wires. But it's also important to know that plastic doesn't conduct electricity. So we can wrap that wire in plastic, because it would be really dangerous to have just a copper wire running around the house without anything to protect us from it. Heat conductivity. Pots and pans are made up of materials that conduct heat to help cook food. They allow heat to pass through them easily from the stove to the food. Most metals conduct heat well. Many kinds of pots and pans are made from cast iron or copper because these metals conduct heat better than the stainless steel and aluminum. You might also notice that most pots and pans have handles made up of different materials from the part that sits on the stove burner to make it safer to hold. Yeah, that's kind of like having the plastic coating wrapped around the copper wire to protect us. So that's why the handles are going to be made up of things that won't burn you, but also won't melt by the stove, right? Heat conductivity, this phrase up here is important. So heat conductivity is really just how much it allows heat to pass through the object. Okay, the next part is magnetism. Matter can be described and identified by its magnetic properties as well. Iron, nickel, and cobalt are metals that are attracted to magnets. Not all metals respond to magnets, though. Try to pick up a copper penny or a piece of aluminum foil with a magnet, and nothing will happen. So magnetism is whether it gets attracted to magnet. You can pick it up with a magnet. So we've learned quite a lot about ways we can describe objects today. We can definitely describe how much matter there is in a particular object by measuring its weight or mass or its volume. And when we think about physical properties, we can think about their color, we can think about how hard they are, we can think about whether they conduct heat or magnetism, whether they float or sink, if they're shiny or dull, how soluble they are, the solubility. So we've got lots of ways we can describe different kinds of matter. And that's important because different types of matter are good for different things and serve different purposes. So in order for us to make good choices in terms of our building or use of materials, we'll have to understand the properties of matter. Okay, that's the end of chapter 1. Now what you're going to do after this video is there's an activity sheet 2.1. You're going to go around the house or your home or outside if your parents are with you, kind of explore some physical properties of different types of matter that are around you. All right, we'll see you next time. Thanks a lot. Bye.